Today we're going to be talking about rules of derivatives. First, let's look at the constant rule. The constant rule states that the derivative of a constant function is 0 if c is a real number. D over dx c will equal 0. Let's look at some examples. The derivative of 5 is going to be 0. The derivative of -7 is going to be 0. The derivative of pi is going to be 0. These are all examples of constants, therefore the derivative of them would be 0. Next, let's look at the power rule, which states if n is a rational number, then the function f of x equal to x to n is differentiable, and d over dx of x to the power of n is equal to nx n minus 1. Let's look at an example. Here we have f of x is equal to x to the power of 5. So here's x, and 5 would be our n. So f prime of x, we would bring the 5 to the front. Here we have our x, and then 5 minus 1, because this is n minus 1, which turns into 5x to the power of 4. So we can see whenever we're taking the derivative of something to the power of something, we can simply use this to get the derivative. Next, let's go over the constant multiple rule, which states if f is a differentiable function and c is a real number, then cf is also differentiable, and d over dx of c times f of x is equal to c times f prime of x. Basically, if you have a constant in front of something you can take the derivative of, you'll just multiply the end result with the constant. Let's look at an example. Here I have the function f of x is equal to 5x cubed. You can see that there's an x cubed here, which we can use the power rule, which we remember as n times x n minus 1. So we'll bring the 3 to the front and then subtract it by 1 in the exponent, giving us 3x squared. Now we remember that there's a 5 in front of it, so we'll just bring it back. So the constant multiple rule, you'll just multiply it out. So the derivative of 5x cubed is going to be 15x squared. Now let's look at the sum and difference rule. And we find ourselves taking the derivative while adding two different functions, such as f of x and g of x, or subtracting them. We would do this by taking the derivative of both of them. Sorry, that's in G. Let's do an example. I'm just going to do the addition, an example for addition. Here we have 3x cubed plus x squared. And we want to take the derivative. So let's find the derivative of 3x cubed. Here we can see the constant multiple rule and the power rule. So let's bring the 3 to the front. x3 minus 1, which we know as 2. Turning this into 9x squared. Now let's take the derivative of x squared. Using the power rule, we'll bring it to the front. Subtract 2 minus 1, giving us 2x. So now the derivative will be 9x squared plus 2x. And that's how you do the power rule. Next, let's talk about the derivative of logarithmic functions. To take the derivative of a logarithmic function, then it'll equal 1 over the natural log of a, which is our base, times 1 over x. Let's look at an example. Here I have f of x is equal to 4 log 2x. Can identify our a or our base as 2. And here we have a 4, which means we'll have to apply the constant multiple rule. So 4 times 1 over natural log, plug in our 2, times 1 over x. So this will equal 4 over the natural log of 2x, which is equal to f prime of x. And lastly, let's look at the derivatives of trig functions. The derivative of sine of x is equal to cosine x. The derivative of cosine x is equal to negative sine x. The derivative of tan x is equal to secant squared x. The derivative of cosecant x is equal to negative cosecant x cotangent x. The derivative of secant x is equal to secant x times tan x. And the derivative of cotangent x is equal to negative cosecant squared x.